Hello students, welcome to my channel LinkedIn Pharma. Today we have discussed about physical and chemical changes. Before starting my lecture, please like and subscribe to my channel LinkedIn Pharma. Let's start. Introduction of physical and chemical changes. Physical change. A physical change is a type of change in which the substance's form or state is altered without any change in its chemical composition. Examples include melting, freezing, boiling, and dissolving. Chemical change. A chemical change is a type of change in which the substance's chemical composition is altered, resulting in the formation of new substances with different properties. Examples include burning, rusting, and fermentation. Physical changes. Physical changes are alterations in the state or form of a substance without any change in its chemical composition. These changes are usually reversible. Here are some examples of physical changes. Melting. Ice melting into water is a physical change because the substance water changes from a solid state to a liquid state. Freezing. When water freezes into ice, it undergoes a physical change, transitioning from a liquid state to a solid state. Boiling. When water is heated and turns into steam, it undergoes a physical change, converting from a liquid to a gaseous state. Condensation. The process of water vapor turning into liquid droplets, such as dew forming on grass in the morning, is a physical change. Sublimation. When solid carbon dioxide, dry ice, changes directly into carbon dioxide gas without becoming a liquid, it's a physical change. Dissolving. When sugar dissolves in water, it is a physical change because the sugar molecules disperse within the water without undergoing a chemical reaction. Cutting or tearing. Breaking a piece of paper or tearing a cloth are physical changes as they alter the form of the material without changing its chemical makeup. Crushing or grinding. Reducing a solid material into smaller particles without altering its composition is a physical change. Remember that physical changes do not involve any chemical reactions, and the original substance can typically be recovered in its original state. Chemical changes. Chemical changes, also known as chemical reactions, involve the transformation of substances into new substances with different chemical compositions and properties. Unlike physical changes, chemical changes are usually not easily reversible. Here are some examples of chemical changes. Combustion. When a substance reacts with oxygen and releases heat and light, such as when wood burns and forms ash and smoke, it is a chemical change. Rusting. When iron or steel reacts with oxygen and water to form iron oxide, rust, it is a chemical change. Fermentation. The process by which sugars are converted into alcohol and carbon dioxide by yeast is a chemical change. Digestion. In the human body, the breakdown of food into simpler molecules through chemical reactions is a chemical change. Photosynthesis. Plants undergo a chemical change in which carbon dioxide and water are converted into glucose and oxygen in the presence of sunlight. Baking. When bread dough is placed in an oven, the chemical reactions between the ingredients cause the dough to rise and form a baked loaf. Oxidation of food. When fruits like apples or bananas turn brown after being cut and exposed to air, it is due to a chemical change caused by the oxidation of the compounds in the fruit. Decomposition. When organic matter breaks down into simpler substances, like composting of food waste, it is a chemical change. Tarnishing. When metals, such as silver or copper, react with substances in the environment and form a layer of discoloration on their surfaces, it is a chemical change. Respiration. The process by which cells in the body use oxygen to convert glucose into energy is a chemical change. In these examples, the original substances undergo chemical reactions, resulting in the formation of new substances with different properties. Chemical reactions. Chemical reactions are processes in which one or more substances, reactants, undergo chemical transformations to form new substances, products, with different chemical compositions and properties. During a chemical reaction, bonds between atoms are broken and new bonds are formed, resulting in the rearrangement of atoms to create the products. Here are some key characteristics and types of chemical reactions. Conservation of mass. In a chemical reaction, the total mass of the reactants is equal to the total mass of the products. Matter is neither created nor destroyed, it is only rearranged. Chemical equations. Chemical reactions are typically represented using chemical equations, with reactants on the left side and products on the right side. Arrow indicates the direction of the reaction. An example of a chemical equation is types of chemical reactions. A. Combination or synthesis. Two or more elements or compounds combine to form a single compound. Example right in below. B. Decomposition. A single compound breaks down into two or more simpler substances. Example right in below. C. Single displacement or replacement. An element displaces another element from a compound. Example right in below. D. Double displacement or metathesis. Two compounds exchange ions to form two new compounds. Example right in below. A. Combustion. A substance reacts rapidly with oxygen, often producing heat and light. Example right in below. Rate of reactions. The speed at which chemical reactions occur can be influenced by factors such as temperature, concentration, surface area, and catalysts. Reversible reactions. Some chemical reactions can proceed in both forward and reverse directions until an equilibrium is reached, where the concentrations of reactants and products stabilize. Chemical reactions are fundamental to understanding the behavior of matter, and they play a crucial role in various natural processes, industrial applications, and biological systems. Rusting of iron. Rusting of iron is a common example of a chemical reaction that occurs when iron reacts with oxygen and water in the presence of an electrolyte, such as salt water, to form iron oxide, commonly known as rust. The process of rusting involves multiple chemical reactions, and the overall reaction can be summarized as follows. Iron reacts with oxygen from the air and water to form hydrated iron, 3, oxide or rust. The rusting of iron is an example of a redox, reduction-oxidation, reaction, where both reduction and oxidation occur. In this reaction, iron is oxidized, losing electrons to form iron ions, and oxygen is reduced, gaining electrons to form hydroxide ions. The rusting process can be further accelerated in the presence of an electrolyte, like salt water, because it enhances the electrical conductivity and facilitates the movement of ions, making the corrosion process faster. Rusting is a significant concern for structures made of iron and steel, as it weakens the material and leads to structural damage over time. To prevent rusting, protective coatings, such as paint or galvanization, coating with a layer of zinc, are often applied to inhibit contact between iron and oxygen, water. Galvanization. Galvanization is a process of coating a metal, typically iron or steel, with a layer of zinc to protect it from corrosion. The chemical reaction involved in galvanization is called electrochemical or sacrificial protection. The overall process can be summarized as follows. In this reaction, zinc acts as the sacrificial metal, which undergoes oxidation to form zinc hydroxide while protecting the iron substrate. The formation of zinc hydroxide creates a barrier that shields the underlying iron from exposure to corrosive elements in the environment. This process is commonly used in galvanized steel, which is extensively employed in construction, automotive, and various industrial applications to prevent rusting and prolong the life of metal structures. Crystallization. Crystallization is a process in which a solid forms from a solution or a melt, with the atoms, ions, or molecules arranging themselves in a regular, repeating pattern to form a crystal lattice structure. This process is typically driven by changes in temperature or solvent concentration. The chemical reactions involved in crystallization depend on the substances and solvents involved. Here's a simple example of crystallization involving the formation of sodium chloride, table salt, crystals from a saltwater solution. In this example, when a saltwater solution, sodium chloride dissolved in water, is left to evaporate, the water evaporates, and the concentration of sodium chloride increases. As a result, the sodium chloride molecules come together and arrange themselves in a regular pattern to form solid sodium chloride crystals. Crystallization is a vital process in various fields, including chemistry, geology, and material science, as it is used to purify substances, produce pharmaceuticals, create semiconductors, and study the structure and properties of materials. Thank you for watching. Please like and subscribe to my channel LinkedIn Farmer.